we have the definition, then we have 4 examples, and then we're done with these notes right here. Scientific notation, the fancy definition is that it's a number expressed, look, here's my abbreviation I told you all about, such that you have whatever number times 10 to some power, you have some number times 10 to a power, the number has to fall between 1 and up to 10, but not including 10. Because if the number is 10 or higher, then you're technically not writing it in the correct notation. You should be able to raise it to another power, and then that would take care of that 10. So there's a restriction on the number. It has to be between 1 and up to 10. Let's see. And n is a decimal. M is an integer. Y'all are used to exponents being integers. The hardest part for people with scientific notation is they forget what direction do you go based on the exponent's sign. And I'm not really sure. I guess it's just because it's intimidating. Because everybody knows what 10 squared is, right? You all know 10 squared is 100. It's 10 times 10. And that's a positive exponent. So you should, if you forget the scientific notation rule that I'm about to write, go back to something simple that you know and just say, okay, so 10 squared is a positive exponent. The number got bigger, which means the decimal was here and it went to the right. Does that make sense? So another way to remember it is what type of numbers are to the right? Positive. And what type of numbers are to the left? Negative. So that's another way to remember it. All right, so let's write this. There's 2 scenarios. You got positive exponents. Move the decimal right. And then negative exponents. Move the decimal left. And the easiest way to remember that is to think of the number line, because positive numbers are to the right and negative numbers are to the left. So I'm going to write think, and then I just drew a little number line. So that's how you remember the rule. And the rest is counting. You're just counting whatever the exponent is, you're counting that many spaces. So I'm going to write 4 practice problems. We'll try them, we'll check them, and then we'll call this little note section done. You are rewriting these in the other notation. So if it's already in scientific, you're writing it in expanded. If it's in expanded, you're writing it in scientific. Okay? That's probably, oh no, oh well. Okay, so this is scientific. Let's see, I'm going to need more room. Let me shrink the. Alright, so number 1, we got 9.46 12th power. I want you to write that in expanded form. And the last two, I want you to write in scientific form. So if you're still trying to decide how to do it, you look at the form it's in. This is scientific, which means I'm going to write it in expanded form. Then you look at the exponent and you see, is your expanded form going to be a gigantic number or an itty bitty decimal, like something like that? Because the exponent is positive, this is going to be a gigantic number. Number two, because the exponent's negative, this is going to be a very small decimal. Then you can also see, because this is an expanded form and it's a large number, then your exponent will be positive, and then this one, your exponent will be negative. The goal, let's see, no, I'll tell you the goal on those two. These two are usually the easier ones because you're just counting the movement. So we're going 12 to the right, and it's from right here. So that counts as 1, 2, and then you just keep going, okay? I think I ended up with, is it 10 zeros? 3, 6, 9, 10 zeros. So in expanded form, I got that. So now let me double check it. So it was here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, this one starts here, but I'm going to the left. So that would be 1 movement, 2 movements. You should have gotten a decimal that looks like this. When it's in expanded form and you're writing it in scientific form, the goal is that your number that you write times what 10 to whatever power has to fall in this window. Okay? So, for instance, red means wrong here. You do not want to say 54 times 10 to some power because 54 is outside of that window. You want to say 5.4. Y'all see that? Times 10 to some power. Now, to figure out the power, find the decimal and you're counting, right? 3, 4, 5, 6, 7. And which direction did we go? Well, we went to the left. Your writing is going to be positive because you want your scientific notation to correspond to what the expanded form was. The expanded form was the big number, right? So we need a positive exponent. So this is where you really don't focus on what direction you're going when you count. You don't focus on the direction you're going when you're counting, when you're going from expanded to scientific. You focus on, did the number get bigger or smaller? This one, so decimals here, we want the decimal to land at, I did 3.819. You see that? 3.8, I want it to land there. I don't want to keep going because then that would be 38 or 381 or 3,819, and that's outside of the window. So I said it's 3.89 times 10, and I moved 3. Now look at it. It's a small number. I've written it as a number larger than that, so it needs to be a negative 3. Because if you look at that and you say to yourself, oh, 3.89, go left 3 times, that would be this. So I find it easier to work from the scientific first, then look at the expanded as a check. When you have expanded to start with, approach it the way that I just demonstrated and then check it. Look back at it and check it. Like if I had 5.4 times 10 to the negative 7, if I'm checking it, then I would be like, oh, it's negative, so it's going this way. That's not right. So then you can adjust as needed. Okay. So now go to the homework and do those problems. The very last problem was an interest rate problem. I will put on the board what the variables stand for. I'll put on the board what the variables stand for. Interest rates, you may remember that. Alpha 2. Yeah. Yeah, go ahead. 13 and 14, that's order of operations. I'm going to give you notes on that today, so you don't have to, who asked? You don't have to do it yet, unless you already know how. But those notes we'll do today as well. P1 plus, and then is it NT? Compounded one? Does it say compounded? Yes. So we're refreshing you on order of operations. And I have 5 practice problems. I'm going to show you something that you may not have seen written in a manner. I know you've seen PEMDAS. This is so funny because if you do follow me on Instagram, I just posted yesterday what can start a fight, and that's if someone says PEMDAS or writes it like that. Like this is crap. You don't write it linearly like that, because that implies that multiplication has to be completed before division. This implies addition has to be completed before subtraction, and that is wrong. That is absolutely wrong. That up here is the correct way to represent it. Let me get rid of this mess. This is the correct way to represent it. I'm going to do a green arrow and show you that it goes from left to right. And I want you to make a note that you read it like a book. You read it like a book. So you look at the problem, you check for any parentheses, and you complete what's inside the parentheses first. So like number 1, here's parentheses. I'm going to try to color coordinate this with a highlighter as I go each step. So you have to simplify the 5 minus 3, bring the rest of it down. Now we still have parentheses, but you're looking inside the parentheses. There's nothing to do. So this means you move to the next order, which is exponents. Move to the next order, which is exponents. What is the cubed attached to? It's attached to just the 2. So 2 cubed is 8. And then now you might think, well, we still have parentheses. When parentheses, let me back up. Parentheses means complete what's inside them. What's inside it. What's inside it is still just a number, so your parentheses is done. Now you look at what operations you have. You have multiplication and subtraction. Once you knock out parentheses and exponents, you read it like a book. So from left to right, I'm going to start reading it, and I come to multiplication, so you've got to do it. And then 64 minus 20. 44, sorry.
I've got 3 minutes.
Okay. Number 2 has 2 types of parentheses. You have the brackets, which is saying, hey, focus your attention, here, right? Then you have within it parentheses, which is saying, hey, okay, now that your attention's in the brackets, I need your attention to now go to what's in the parentheses. So what is 8 minus 5? That's 3. So I'm going to bring all this other stuff down. Then you look and see, okay, so now my parentheses here are done, but these brackets are a set of parentheses. So you're going to do what's in there.
You see interruption at this time. This is the last call for anyone who needs to have their picture made. If you have not had your picture made either yesterday or this morning, please report to the auxiliary town at this time. Last call for your pictures right now.
You're going to read it like a book from inside the parentheses. I've got subtraction, which means can't do it yet because what's this? That's multiplication. So that's going to copy down to become 12. I'm going to change those brackets to parentheses now since I don't need them anymore as brackets. And then now you have to do what's in here. You can't multiply. Is that negative 5? Your homework is those 3 practice problems and the 4, isn't that two?
4 and then those 2 that we didn't.
There should be
There's 2 on here.
2. Oh, there's 2. Your homework is those 3 and the 2 that are on the worksheet from last night. 13 and 14. You should now be able to try them. Just try it, okay? You can try it, send me a pic and be like, Holcombe, I don't know if I got this right, and I can give you that confidence. Or I can completely crush your dreams, either one. I wouldn't do that. I would just say, come see me.
It's very slow.
I will remember that.
No
You need another cup tomorrow?
Are you going tonight?